It's not free. That one is a licensed version and it's very expensive. Apply has having the SolidWorks license. So using SolidWorks, you can design the casing part. Okay, that is just close to the product. So you can see here, I have mentioned the left hand side. The left hand I can see. So I have designed a circuit board with having ESP32 and weather sensors. This one already done in the left hand side. Then I have given that to 3D model printing. After 3D model printing, that was the casing part. The casing part you can see over here. This is the after casing part. This product will be looking like this. So this product now you can do the commercialization or you can release it for beta testing version. So this is just I am showing one product. This is another version. It can be used for vehicles. It can use for vehicle tracking. It can use for vehicle accident detection. It can use for other aspect of vehicles. So that is one of these. Then now I'm just going to say something about some case study. This is whatever I already mentioned about. This is one case study, and this product is used for accident detection. And this product is having very well-known sensors. Like you can see over here, there are temperatures. There are IME sensors. Then there are GPS sensors. And also there is another pressure and temperature sensors are there. So based on GPS giving you the location, and IME sensors will be giving you the information about the vibration, acceleration, everything about the vehicle. So based on that, you can say whether there is accident or not. That based on that, and you can inform to the vehicle owner. And I mentioned the architecture of that. Like the sensor need to be connected to microcontroller. Then microcontroller will be connected to cloud through Wi-Fi connections. And from cloud, we can access those, you can trace those information, whatever you have stored from the sensor, and you can develop mobile app and web app. So in this architecture, you can see there are three different components. One is front end. Front end means web app and mobile, and backend is sensors and cloud servers. The cloud server can be local, cloud server can be remote. But remote cloud servers are very expensive, like Amazon server, Google server, those are very expensive. You need to pay as per your requirements. Okay. But local server, suppose your PC, your desktop, you can make it as a local server where you can install MySQL, which is free, MongoDB, which is free. Then these are the two different databases which are free. You can install in your laptop or system. And if you are a commercial version like Oracle, SQL, those are commercial version. You need to buy for them. So in your system, you can make it as a local server, and you can implement all this data. Like when you have developed on the model using ESP32, and you are collecting information from the sensor. Those sensor information you need to store in backend, that is database. Either you can use MySQL or MongoDB. Okay. So this is one case study and a very generic way of saying how do you develop a very simple product based on your requirements. This is another one. As you can say, the previously I was saying this. He said something about how to transmit information. The radar is just to detect objects, but after detection, what is next? So you need to transmit some of the information. How to transmit information efficiently and with high-speed networks. So this is one of the applications you also can develop this. This is the application of free space optics. You can transmit signals wirelessly through laser for long distance communication. For that is outdoor communication. For indoor communication, you can use Wi-Fi technology. Wi-Fi technology is the very latest technology, light fidelity system. which is the replacement of Wi-Fi communications. Okay, so either you can use FSO or you can use Wi-Fi technology. So this Wi-Fi and FSO technology will be well suited for undermined communication system. As Mr. Das already mentioned, how to communicate inside the mining sectors. There is no suppose there is no signals. So you can use this kind of technology for that. This is the application of 5G. This is the application of 5G which is recently going on. How to improve, how to provide high-speed networks using free space optics. This is another application, another case study you can say. Just now, data scientists mentioned about radar technologies. This is one radar, very simple radar I found from internet from Google. That is the HP100, HP100 radar. You also can develop this one. These are very simple. You just buy this radar. This is around only 2,000 rupees. This radar is 2,000 rupees. Okay, and it detects up to 20 meters distance. The range is 20 meters. Okay, so I have connected this radar to Arduino Nano. Then I have connected Zigbee. Zigbee is for data transmission. So whatever I detect information using this radar, I am transmitting that information to receiver. That is the receiver sections. You can see receiver. That receiver is also having ESP32 and Zigbee. So it is Zigbee to Zigbee transmission. So it will transmit up to 20 meters. Okay. So this is also same like you can manage everything through IoT. I say IoT concept, right? IoT is nothing but it is a networking. How do you connect from one device to another device? It is a communication path. You know, in communication domain, there are two different paths. One is control path, other one is data path. Okay. So this one you can use as a control path. Okay. So for any kind of control path, you can use either Wi-Fi, you can use Wi-Fi, or you can use FSO, you can use Zigbee, you can use LoRa, or you can use any kind of networking, like RJ45 connection. So this product. It can be used for drone. It will be a part of drone technology. Nowadays you can see drones. They are using lots of techniques how to detect intruders, intruder detections. You can say what kind of drones are coming to the prohibited areas that can be detected and immediately that can be transferred to the destination. So this is another application. I can say this is actually the picture I have not mentioned over here. This is a kind of IoT products where you can detect any kind of gas sensor related to pollution. I mentioned there are 7 type of pollution parameters: CO2, CO, NO2, and SO2, like that. And this is also very simple. Is just buy these sensors and connect to any of the microcontroller, either ESP32 or Raspberry Pi. Because now the Raspberry Pi is coming with 16 GB RAM, so that is enough for processing. So you can do Python programming. That is a micro Python programming. Nowadays it is there. You can do Python programming. I think everyone, the BTech students, they know Python programming. Okay, and in industry also people are using Python programming. Other than that, in the DRDO, I had long back, I had discussions. They are always prefer C programming. Always they prefer C programming. They don't like Python or anything else, right, guys? So they only prefer C, and they don't want to use other library as well. You have to develop your own libraries. Python is full of libraries, third-party libraries. They don't want to use libraries. Okay, you have to create your own libraries so that there will be security. Okay, so that is the way how you uh, 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 develop your skill based on your objectives, whether you want to join in DRDO or ISRO or somewhere else or IoT industry. But in IoT industry, they prefer Python, Java, something like that. So this is another one that is very simple. Uh, I developed it's a connection type of. This can be connected to any microcontroller, and using the microcontroller, you can connect bulb, light, fan, fridge, etc. Anything you can connect. This is just a product. This is related to camera. So now everyone is using AI ML, right? So this can be very suitable for students who are interested in AI ML programming and just take any IP camera, connect to your LAN points or directly connect to your systems and use Python programming, use AI ML and just stream the IP camera feeds, then just try to extract what are the information you want to read. So this can be used for like criminal activity detections and alerting to the house owner or a company owner or something like that. So this will be very useful. And these are nowadays you can get it from YouTube also. How to program IP cameras for different type of criminal activities. So I already mentioned about actually IoT. What is that? So no need to explain. It's just the things, anything you can connect to internet. That is called IoT. So these are the processes already I have mentioned. Right? And IoT, of course, the features. And this is how does it will work. This is the vision of IoT. Like when it was started in 90, then now it is 2023. In 2020, you can see that 50 billions of devices are connected to internet. Now it must be around 100 billions IoT device. So that is the strength of IoT applications in recent months. These are technologies related to IoT. Everyone might be knowing all these things. And the application why people are using IoT in industry just to save money, right? You see how the people, industry people, aviation, power, healthcare, rail, oil and gas, how they are using IoT concept and saving money and getting a very profitable business. And these are the challenges everyone can work on. And challenges means you can do research and you can work on these topics. Like system design, data management, device management, service management, and securities. Like this, why you need all these challenges? Because microcontroller is a very small device. IoT device means it is connected to sensors. Sensor means you need to connect to some microcontroller device. Those are very tiny devices with limited memory access. So that's why there are lots of challenges are there. Like how to manage? Like as I mentioned, there are 100 billions of devices already connected to internet. There will be giving huge number of data. That big data concept is coming there over there. So how do you manage the data? The data management is an issue. Device management, there's so many devices are there. How do you manage those information? And security is another issue. There are so many challenges. And mostly the IoT concept now industry people are adopting very fast and they are using because from mobile also they can control machines. Okay, that's why it has very high demand. Next, next. Okay, these are some of the disruption. How people are getting benefit out of IoT applications. See, like if you take any of the examples, like Uber or Ola, they don't have their own taxi, they don't have their own vehicle, right? But they are earning lots of money. They are billionaires because of IoT applications. Only they develop one simple app, just booking app, right? They're earning lots of money. These are the IoT disruptions. How only few people are getting benefits. Okay. These are architecture of IoT, like how it started from physical layer to application layer. It is the same like OSI 7 layer. Okay. And it's a very generic block diagram of IoT. Like how do you sensor to microcontroller, then database, then application. That on the block diagram. Sensor need to be processed, then you need to store in database. Okay. And now making product means how do you make a IoT products? There are steps are there. Other than East West, I have mentioned 13 steps in US management. Other than that, these are the 8 steps. How do you build an IoT device? The first one is you should have a proof of concept. You should have an idea as I mentioned in the beginning, that was the idea that you should have some idea, innovative idea, so that you need to produce one IT device. So you should have an idea. That idea should be proof with proof of concept. Then after that, you need to convert to the block diagram. Second step. Third step is you need to convert to the schematics for fabrication. Then bill of materials. Then step 5 is you need to develop a prototype. Step 6 is field testing. Then after field testing, that will for 3 to 6 months. Then beta version. Beta version will be just to get feedbacks about your product. Then step 8 production. Because after beta version, if everything is okay, you can go for mass production. Then last one is releasing our product with documentation, manuals. That is for commercialization. And potential wise, you can say it has high potential. As I already mentioned, right? So these are the sensors available in market. You can use, you can buy it, and some of this example. Just, these are the technologies. How do you connect IoT devices? These are the applications. And okay, yes. I have prepared so many things. I am just passing on. Okay, next. These are microcontroller devices. Yes. Some of the case stories you can see this is used for action. This device. Okay. So this is related to crime. Whatever crime. Attack. For traffic detection, this one also you can develop. I think that's a yeah. Thank you so much. So we'll arrange one workshop related to this later to know in depth about all these product developments.
Thank you, Dr. S.K. Das, to elaborate on IoT. So I also know Dr. A.K. Panda, sir, actually he has done plenty of work on this field of device. So now it is a open session. So any questions within 5 minutes, so that because we are slightly delayed of the schedule actually. So that we can go for a tea break after Dr. A.K. Panda's talk. Actually.
Yes, sir. Good morning. So I would like, hello, sir. So once your product is developed, okay, sir, then how to commercialize it so that it can reach to the market. So if you can throw some light on that. After developing the product, how to make it marketing, reach out to the market.
Actually, once product is ready means you can directly do the commercialization. Some of the cases you need license, but some of the cases you don't need license. This whatever I sold that product, directly I can sell it without taking any permission from government.
So where to sell it? Like if some companies are helping in.
No. Companies are not going to help you. It is you only. You need to help by yourself. Because you need to convince. Suppose I have developed one product, I need to convince the customer. So this is my product. You use it. First, better use it freely. Then after 1 month, get the feedbacks. Then if he likes, he will sell it. You can make like 1 month license. So that device will be working for 1 month only. So after 1 month, we can talk to the customer directly. But companies will be helping you if you are a partner of it. They will be getting money from you if they want help. Like investors, they will be investing money on you, but they will be getting return. Okay. So for product commercialization, it is ordinarily up to you.
Thank you, sir.
So I think Dharamveer is asking about B2C, actually B2C kind of thing actually. From the direct customer, how he can reach. Suppose in the laboratory he has developed a product, and suppose you want to sell it or commercialize it. So is there any regulation needed, or directly he can approach?
No, no. As all things, the product can be sellable through a company. You need to have a startup. That company should be registered under Government of India. Government of Odisha. After registration, it can be like private limited, proprietary. So you need to register your company first. But directly you cannot sell that step actually. So you need to register your company.
Thank you. So I think any question from student side or something you need to ask. Few questions can be taken. So yeah, please pass on the mic.
Good morning, sir. Sir, can you please explain how the IoT device is used to detect the heart attack?
Okay. Heart attack actually it gives lots of information like pulse rate. Okay. Pulse rate, then but that you can measure using oximeter. So pulse rate means how do you measure pulse rate? Using some sensor, right? That sensor need to be connected to one microcontroller. Okay. And if there is some threshold of heart attack, like if it is above 98, something like that, that's 100% that is heart attack. So that time you need to inform the doctor. There is a golden period actually. Within maybe within 5 minutes or 10 minutes, there is a golden period of heart attack. Within that time bound, you need to inform doctor. So that patient can be saved. But that need to be detected either using oximeter sensor or some other sensor. Then there is some other medical parameters are there. That and those parameters also need to be measured.
Thank you. So because we are delayed in schedule, so we can go with the next speaker. So thank you. Thank you, sir.
Thank you so much.
Our next speaker is Dr. Ajit Kumar Panda, sir. So he is the Vice President, Engineering RF, PVD and Technology. I welcome you, sir, to the dais. So to read out the brief bio, Dr. Ajit Kumar Panda, a Boycast Fellow with a postdoctoral from University of Michigan, worked in academia for 25 years and jumped into industry in 2020 during Corona and set up a unit of VVDN technology, a ODM and OEM company at Bhubaneswar, where more than 100 hardcore electrical engineers are working on 5G, networking, Wi-Fi, vision, IoT. Dr. Panda is now Vice President Engineering RF for VVDN technology and responsible for all RF related activities of 5G radio networking and Wi-Fi access point and CP devices, camera, etc. He has guided 15 students for PhD and a distinguished lecture of IEEE Electron Device Society and is a vice chair of IEEE South Asia for chapters of ED Society. He has delivered lecture through IEEE ED Society as a distinguished lecturer for more than 10 countries, and he has taken a noble initiative to develop an electronics ecosystem in Odisha. Thank you, sir. So, please, it is up to you.
Yeah. Good morning. Yeah, looks all like that. Good morning. Great. Good. Thank you for inviting me. The first point, respected Vice Chancellor, my old Bonsi Dada, for last 32 years time. He has seen my ups and downs. Respected professors from the GSSUD with whom actually at least I have associated. And this is one of the cause actually. my previous speaker speaks about right, because for this and that they have come. I have come only because to enjoy it actually. Just for enjoyment actually. Just to see the old friends. Just to know I know Professor Bansimuji, the Vice Chancellor, he is here. As I said that right, my Bansi Dada. Intentionally I did not call him because he is the Vice Chancellor now. And maybe that I will disturb him or something might be. But I would like to tell you that with his busy schedules also, at morning 7:30, he called me from his side. It is not that I call him, he called me from his side. That's the networking, and that's the business part actually. We need it. Therefore, thank you, Professor Roshi. When I see my old colleague, Dr. Arunanshu, Dr. Siddharth, immediately I took a photo. And the new age technology are talking, right? Immediately I took a photo and I spare it in some groups. Immediately he said by 100 old friends, around 100 old friends. He's sitting there, he can say that. That's the basically, new age technology we look for. And hence, thanks to Dr. Harish for inviting me to this lecture. Coming to the quickly, I will come to the topic. You are telling that right, new age technology. Since it is a final discussion, so I would like to tell that is it necessary? Are we acquainted and are we ready basically for the new age technology? I say that we are not actually. Maybe that one or two cases it may be. So maybe that Dr. Malik said the new age technology for the defense, for the radar, for the applications it may need it. And when we say that there's so many flights detections is there. Actually, tomorrow I'm traveling from Kolkata to Delhi by flight. So I thought that, just a microsecond, let's say, gap is there, then that fast will get crashed and maybe that I will be a problem. So that's necessary actually for the new age technology. Then when Dr. Santosh told about that 102 billion or some 20 billion IoT devices can be connected, immediately I thought that, from each one, if I can able to save ₹1, then we'll have a $20 billion actually. $20 billion enough basically for the sustainability in the Odisha itself. That's what actually I think. So I'm not sure, that is possible or not. But that is the dream. I think one night actually I will think, can I make these devices the commercializations and can I able to get the $20 billion? Maybe that I may not be. So out of that, one sense it will come to me also. If $1 billion also, maybe that, I will surpass the man Murthy and maybe that, I don't know. So that's basically the mindset. So when it comes to the new age technology and when we are talking it, I'm very sorry to say this, few of you guys may think that, often that time, you might feel that I am good thing to myself, egoistic, you might be telling, but I'm sorry that actually if you think it also, but hardly better actually to me, if you think it also. But mind it, India cannot make a single diode till today. Single diode which cost less than a cent, India cannot make it till today. And there is no any commercialization of the single diode. Tell me anyone, organizations otherwise, tell me anyone who actually can make a diode in India, self-sustainability. So in research and all that, people will talk, I have done this, nanotechnology, that I have done this. That's fine. But can we make a single cell diode by ourselves? Till now it is not possible actually. Therefore, can I think about a 2 nanometer technology, or will I be okay to having a 180 nanometer technology also and to have the diode, where actually we are using more than billions of the diodes per year. And in each of that, if I can able to send, if I can able to save a cent, then that will be sufficient actually. Then that will be sufficient. Therefore, I think, whether it is needed or not actually, new age technology or existing technology, whatever is there, can we able to make it sustainable? If so, I think, we will be self-sustainable. I think we will be self-sustainable. No doubt, we need it, the new age technology. Otherwise, India will not become. Chandrayaan will be there. It is a lot of them to us. New age technology is needed, no doubt on that. But simultaneously, our mindset should be can you able to make it commercialization with the existing technology, and can you able to make it sustainability? That is what actually my take is. The other speakers may tell it against or and the students you can think about it. But that actually I would like to say. I came today by a train. It is from Bhubaneswar to Sambalpur. It is a 4-hour journey. It is a 4-hour journey. It becomes 1 hour late. Okay. My brother is was waiting there at night too, wasted his time. Out of the 4 hours, 1 hour late, 1 by 4 efficiency, 25% efficiency I wasted without doing anything. Is it allowed? Whether I need a bullet train or whether this train, which actually did a 1 hour late, that actually should at the right time. Think it. Again, now I will be going from here to Kolkata, and just I got the message at 10:18 actually sitting from here, and he's saying that the train is already 1 hour late. Okay. Tomorrow I will be going from Kolkata to Delhi by the flight that I told you. Already from Vistar I have got a message that the flight will leave at 9, half an hour late. Already it's told you. Is it? The newest technology we need it, we should make all these things proper so that there will be a lot of sustainability. I usually go to Japan. After joining this, actually, some Japanese customers are there. So every year I am going to Japan almost. In last 4 years, I have gone 2-3 times. And every time I meet people like you, the students, my students who are there, actually, I meet them. And every time, they talk it. The different people, even this NEC, they talk it, In Japan, one train got late for 1 minute. Therefore, their railway minister has resigned it. Therefore, you imagine, if we take that new age technology and if we talk it like this, then how many railway ministers from India will have been resigned in the meantime? You think about it. One, so maybe that railway minister, this aviation ministers, everybody would have been fired every day. So in the meantime, maybe that in 365 days, there may be 730 railway ministers, 780 aviation ministers. Do that, make it very proper, and can we able to sustain with that? If we able to do that actually, and if we can able to reach it actually, then maybe that 95% of our goal will reach it. No doubt, on 5 or 10% actually we may have to do. Yeah, you can only do. So 5 to 10%, maybe that 10% I may need it. We may need it for the new age technology. As I told you, right, the existing technology, just you tell me when I have to stop it, otherwise I will go on speaking for hour and hour. Sorry. So, I was working at the very beginning actually in 2010 in part-time. It is at 94 gigahertz. Okay. Working at 94 gigahertz, I published a lot of papers in IEEE. For that, actually, I got the IEEE distinguished lecturer. And, for that, actually, I could able to go to some 17, 18 countries. And what he's telling that, because the vice chancellor or vice chair for the IEEE Society of the South Asia. Does it have any meaning to me now? In fact, tell me at 94 gigahertz, maybe that, maybe that in radar or maybe that in space applications, it might be using it in 2%. But at 98%, there is no use of that actually. Therefore, I changed my mind actually. I changed my mind. All these are good things, basically doing the new age technology, new age thing. Instead of that, can I do the existing technology and can I able to get some money from that actually? And can I able to develop the money where actually I can able to sustain it by myself, as well as I can able to sustain some 100 engineers. Then actually it will be far better than me than doing the new age technology research and getting some IEEE paper. I'm sorry to say to the faculty members, really I'm sorry actually if it has hurt to anyone actually. Therefore, will I do a metamaterial antenna? Where antenna topics also it comes with right. Metamaterial antenna which costs some maybe that 100 USD and many people actually, many antenna which the one topic be almost all the engineering colleges of engineering colleges, university was on actually. But same questions actually after joining in the industry, I have asked to many of these guys actually, those who are actually so-called fellow of IEEE on antenna also. Can you able to design a AM FM antenna for me? AM FM antenna, we know it from 92 at least, I know it. Akashvani Patako, 392.2 megahertz radio re Kochi Kono Kono. That AM FM antenna, I realized it, I researched it, I found it. I will show you one slide actually. Till now, actually, nobody is doing. Just simple, leave about the diode. Just simple antenna, it is just a metal piece. Just it is a metal piece. Nobody in India is doing it for commercial edges. Okay, and you see in Burla itself, how many cars are there? Let's say car, AMFM, where actually it is using. Maybe that some 20,000 cars might be there. In 20,000 cars, maybe that 20,000 antenna is using it. And if I can able to only to sustain it into the Burla town itself, and each of that actually antenna I will make it this AM FM antenna, which actually using in the automotive and the car available in Burla only. And if each of that, if I can able to save $1, then actually I can able to save $20,000. $20,000 is 1.6 crore, or good amount of money to me actually, and I can sustain my life very easily if I can able to do that. That basically is the challenge, and hence my stake is no doubt we should have the new age technology. No doubt we should have, otherwise we cannot sustain or we cannot go at par with the old world actually. But simultaneously, you think about it. Can I able to make the existing technology, and with that actually, can I able to get some money, generate some money? That is my mindset, unfortunately, but that's the true fact actually. So, I don't know, you believe it or not, but that's the true fact, which actually we have seen it. Therefore, relating to that actually, I will try to show some slides, 1 or 2 slides only I will show you. I think, after that, let it be open and anyone can ask any questions. So, for people like me actually, or people like you, the young generations actually, I'm not telling to faculty or panelists actually, you have to decide it actually. You have to decide yourself. I will tell you my case story again, I will say that today, I came back from USA, say that bloody I could have otherwise, a very good life at USA, came back and work in the private engineering college. Basically, my aim was to can be able to develop some engineers from some private engineering colleges and can be able to get some good job where actually they can able to sustain to their family socially. After that, actually one day, 20 years I worked in Dr. and after that one night, I decided that I will leave this academic. I will go to the industry. When it comes to the industry, basically I tried to get it from, and one company, this Vividian Technology, asked me, can you join with us at Gurgaon? I tell that either I will work at Odisha or I will go back to USA. If I can able to do some things and if I can able to develop it in Odisha, then it is fine. I don't want to go to Gurgaon. I'm not telling that Gurgaon is a bad place or not at work or something. I'm not telling you. My mindset. And they compelled to do it. They compelled to do it because I work on the age technology. I'm not telling that new age technology, but age technology, where you will work it, where industry needs it. For example, like it said that RF and microwave engineering. RF and microwave engineering. There are very, very few people who have some expertise on RF and microwave engineering. And if you can develop a group, actually, you can be able to play with the systems. You can play with the system. Therefore, we work on that particular area actually to have that. And I'm happy to say that now more than 100 engineers from Odisha engineering colleges are working on exact electronics, hardcore electronics, and getting the salary far better than what actually they get in electronics industry in Bangalore or maybe that in Hyderabad actually. And I'm proud to say that actually. And I'm proud to say again, because the students from Odisha, few of them decided that yes, but the sustainability of Odisha in the industry, electronic ecosystem has to be developed. Like that part actually is developed in the IE. Therefore, we choose one area. I will tell you 2 points to this young generation's time. This is a whole system actually. The so-called 5G systems we are talking it right. Many of you guys might have heard it, and Dr. Shah also told it during these 5G inaugurations. The Prime Minister said that, this said that, and all that actually. In that 5G technology, till today, nothing has been done. On the other side, you might have read it in the papers and all that, right? The India government recently sanctioned 75,000 crore to the BSNL to set up the 4G. You guys will not agree with me, but I will give the paper otherwise I have. And it is true fact. BSNL is now doing the 4G technology and setting it up. I'm a part of that. I'm getting some money from that. Therefore, I'm that sure. So 5G technology, how many are using it? Does it need it? I'm doing it, so I will say that yes, 5G technology needed it. Without that, we cannot survive this life, we'll say. But let's just suppose, from here, go to that Iraq to the Vistapita Anchala. Iraq to the Vistapita Anchala. Can you get it? Can we get the 5G technology there? So why we talk about that? Can we able to give the sustainability of the 3G, 4G existing one only? That is my view. So with the existing technology also, if we can able to reach to each and everybody, then actually, I think we'll be able to get the real things actually, and it will be sustainable. It will be sustainable. Anyhow, everybody is doing it, so I am also doing the 5G technology. And this is one full set of things for the 5G technology.